one of the key characteristics of design is that we're trying to solve a problem. But often, we're not only required to solve the problem, but also to identify the constraints within which the design has to be developed. A well-defined problem and constraints help us frame and guide the design process. Typical constraints include smallest economic cost, highest technical quality, this means structural or environmental efficiency, sensitivity to the site, limited resources, limited time. The final design will satisfy all the constraints. In your first design experience, we place you in the position of the engineer asked to design the Sabrina footbridge. You will first practice this first step, identifying the constraints and goals implicitly associated with the design problem. I want to emphasize that constraints are not necessarily a negative limiting factor. Let's look at an example of one of the projects that I worked on for a pedestrian bridge. In 2006, I worked on the design of the Verviers footbridge. The project had a few constraints. Firstly, there were existing foundations on site. We decided to reuse the foundations for the new footbridge. The client stated that the river could not be closed during construction, so we decided to make a prefabricated bridge. We imposed a constraint ourselves. We wanted to make an aesthetically pleasing bridge and opted for a geometrically patterned rail. Of course, the budget was a high constraint, which meant minimizing material and labor cost, so we decided to use optimization techniques and CNC machines. The design, motivated by these constraints, did end up being the selected design with the lowest cost. The constraints were not negative limiting factors, rather, they steered the design process. In the required reading, you will see another example of a design process that is motivated by its established constraints. Jörg Schleich briefly goes through the design process of the Ting Kau Bridge in Hong Kong, a process driven by its constraints.